Hello and welcome. So, we're told that given a parallelogram, ABCD, right, we're told that BE, the segment BE, is 12x plus 96, BD is 6x squared. So, first off, B to E is going to be this little segment right here. We're told that's 12x plus 96. Then we're told that BD, which is not just part of the segment, but the whole line itself, is going to be 6x squared. So your first question, when anything geometry related, is always going to be, all right, what's the relationship? How does BE and BD relate to each other? Well, we know there's a particular property with parallelograms that when you have two of your diagonals, right, when they meet, this point E, we call that the midpoint. Okay, it's going to meet directly in the middle of both of these lines. That is the direct middle of both lines, which means that BE and ED, that segment, those are congruent to each other. So if this section was 17, this section would also be 17, and the whole thing would be 17 plus 17, which is 34. Okay, and the whole segment would be 34 altogether. All right, and that's going to be true no matter what you have. Which in this case, we're told that BE is 12x plus 96, which means that the other section ED must also be 12x plus 96, and we're told that the whole thing should be 6x squared. But we also know that it's more than just 6x squared. We also know that it's a 12x plus 96 and the 12x plus 96 combined. So if you take 2 over 12x plus 96's, that should be the exact same thing as 6x squared. Okay. Another way you could set this up, okay, an equivalent way to set this up is you could say, okay, well, we know that it's 2 of the small portions to give you the big one, or you can take half of the large portion of our blue line, BD, and that should equal 1 of these smaller portions. Okay, either or, these are both totally correct setups. Okay, whatever floats your boat, go for it. It does not matter which way you go. Okay, so I'm just going to go with this initial setup that we have over here. So I'm going to multiply by 2, right? So I'd say, all right, so then we have 24x plus 96 times 2, which is 192, equals 6x squared. Now you just need to solve for your x, right? Hopefully, as soon as you see that x squared, you should be getting like bells ringing, like, oh wait, yeah, I need to solve for our x squared. And the only way you can do that is one of 3 ways. You can either factor, use quadratic formula, or complete the square. I like factoring. We're going to use that. Okay, so I'm going to subtract the 24x as well as the negative, so as well as subtracting the 192. Now the reason why is I like my squareds being positive, so that's why I'm moving everything to the right side. Couldn't you move the 6x squared to the left by subtracting it? Heck yeah. Alright, will you get the same answer? Yes. Okay. And then from there you would just solve. So if we're solving by factoring, my first step would be to take a GCF, which is 6 in this case. So we have 0 equals 6 parentheses x squared minus 4x. 192 divided by 6 is 32. And now you would just finish factoring from there. So your middle number, negative 4. Your first 1 times negative 32 is negative 32. Now there's only 2 numbers that is going to work here. That is going to be 8 and 4. To get to a negative 32, we're going to have a negative 8. So negative 8 plus 4, negative 4. And then negative 8 times 4 is negative 32. Those are your numbers. So then we have 0 equals 6 parentheses x minus 8, x plus 4. We can go straight into those factors only because we have a positive 1 in front. If it wasn't, you'd have to factor the long way. Okay, and then from there, you'd say, all right, great. Now we have our 2 factors. You have x minus 8, set it to 0. X plus 4, set that to 0. And then you can solve your equations. That's like a squish 0 right there. There we go. So the first one, you would add 8, x equals 8. Next one, subtract 4, x is negative 4. right? You wouldn't have to worry about the 6 that doesn't make a solution because there's no x attached to it. So then you have two solutions. You have 8 and negative 4. And then from there, all you'd have to do is you just have to double check, like plug them in. And when you do, you're going to end up getting maybe one of them fails, maybe one of them doesn't. If they both fail, then you wouldn't have a solution, right? So first off, let's plug it in. So first, let's try x is 8. Okay, so if we do 12 times 8, we're going to get 96 plus another 96. We get 192 when we plug 8 in for our x there. If we plug 8 in here, we get 8 squared, which is 64, times 6 is going to get 384. Which they're both positive numbers. Awesome, right? Distances can't be negative, which means that 8 is a valid solution. Okay, now the length of BD, we just found that. When x is 8, 384 was the number we got back. Huzzah! Okay, now let's try negative 4. Let's make sure that that still works as well. So now we're going to try negative 4 in instead. And when we do, we get 12 times negative 4. That's going to be negative 48 plus 96 is 48. Okay, now plug negative 4 into our next one. So we have 6 times negative 4 squared. Negative 4 squared is 16. Right? Negative times a negative is a positive. 6 times 16 is then 96. Both positive numbers, which means that negative 4 also is a valid solution. And then when we plugged into BD, we got 96 back. So you have two possible lengths for BD. If x is 8, that length is going to be 384. If x is negative 4, then 96 will be the length that we get back. Okay, it's an either or situation. They're not both going to be true at the same time, but you have two cases, right? It's one or the other. And that would be it. You'd be done. That'd be your answer. Thanks so much for watching.